Welcome back everyone. Today let's see the next 20 question and answers. First question, neptunium is formed when uranium 238 is bombarded with dash. In the chain reaction, 3 fast neutrons are produced from the fission process. After passing through the moderator, it gets slowed down. One of the slow neutron is captured by uranium 238, which decays to neptunium 239. Hence, the answer is option C, slow energy neutrons. 12th question, if the value of Rydberg constant is 1.097 into 10 to the power 7 per meter, then the wavelength of the first Pascal series is dash. Let's write the given data. R equal to 1.097 into 10 to the power 7 per meter, N1 equal to 3. To find the wavelength of the first Pascal series, we have to take N2 equal to 4. According to Pascal series, nu bar equal to 1 divided by lambda equal to R into 1 divided by 3 squared minus 1 divided by N2 squared. By substituting the values, we get 1 divided by lambda equal to 1.097 into 10 to the power 7, 1 divided by 9 minus 1 divided by 16. That is 4 squared is equal to 16. By taking LCM, we get 1.097 into 10 to the power 7 into 7 divided by 9 into 16. Taking reciprocal of these values gives the wavelength lambda equal to 9 into 16 into 10 to the power minus 7 divided by 7 into 1.097. After simplification, we get 18.752 into 10 to the power minus 7, which we can write it as 18,752 into 10 to the power minus 10 meter. 10 to the power minus 10 meter is angstrom. Hence, lambda is approximately equal to 18,752 angstrom. If you would like me to simplify the numbers step by step, please let me know in the text box. The answer is option A. Third question, when there is a transition from infinite state to ground state in a hydrogen atom, the wavelength of spectral line is dash. Here the term RH is the Rydberg constant. From the problem, let's write the given data. N1 equal to 1, N2 equal to infinity. We have to find the wavelength of spectral line lambda. Solution, nu bar equal to 1 divided by lambda, which is equal to R into 1 divided by N1 squared minus 1 divided by N2 squared. By substituting the values, we get 1 divided by lambda equal to R into 1 divided by 1 squared minus 1 divided by infinity squared. 1 divided by infinity is 0. Hence, we get 1 divided by lambda equal to R. This implies lambda equal to 1 by R. Hence, the answer is option B, 1 divided by RH. Fourth question, an atom whose Z or N is equal to the magic numbers, the value of binding energy in the binding energy curve is dash. Already we have seen magic numbers in the last video. The magic numbers are 2, 8, 20, 28, 50, 82 and 126. From the binding energy curve, it is clear that between the magic numbers, the curve has several spikes. Hence, the value of binding energy in the binding energy curve is high and discontinuous. The answer is option C. Fifth question, which one of the following is a new family of leptons? The elementary particles are classified into several groups. According to that, initially the lepton group contains photon, neutrino, electron and muon. The new family of lepton is tauans. Hence, the answer is option A, tauans. Sixth question, the time interval measured by a clock at rest relative to the observer is called dash. The exact words are obtained from modern physics book. Learn the book thoroughly. The answer is Option A, proper time interval. Seventh question, the normalized wave function should satisfy which one of the following relation? The answer is option A, triple integral of modulus of psi the whole squared into dx dy dz equal to 1. Eighth question, the conservation of probability density of a quantum particle is given by dash. The answer is option B, dou by dou t of psi star psi plus del dot j equal to 0. Ninth question, what is the de Broglie wavelength of an electron having kinetic energy 1000 electron volt? The given data, kinetic energy E equal to 1000 electron volt. We know 1 electron volt equal to 1.602 into 10 to the power minus 19 joule. Hence, E equal to 1.602 into 10 to the power minus 16 joule. We have to find the de Broglie wavelength lambda. The de Broglie wavelength lambda equal to h divided by root of 2me, where h is the Planck's constant. Its value is 6.626 into 10 to the power minus 34 joule second, and me is the mass of the electron. Its value is 9.1 into 10 to the power minus 31 kilogram. Substituting the values, we get lambda equal to 6.626 into 10 to the power minus 34 divided by root of 2 into 9.1 into 10 to the power minus 31 into 1.602 into 10 to the power minus 16. Multiply 2 into 9.1, we get 18.2, and simplify the power terms, we get 10 to the power minus 47, that is minus 31 minus 16, we get minus 47. Make the power term as even number, that is 10 to the power minus 46, by writing 18.2 as 1.82. The even number of 10 to the power minus 46 can be easily taken out from the square root, that is 10 to the power minus 23, and roughly we can write the square root of 1.82 into 1.602 as 1.7. Because within the exam time we don't have that much time for perfect simplification. Hence lambda equal to 6.626 divided by 1.7 into 10 to the power minus 34 plus 23, we get 10 to the power minus 11. This we can write it as 66.26 divided by 17 into 10 to the power minus 11. By cancelling the numerator and denominator, we get 3.897 into 10 to the power minus 11. Hence lambda is approximately equal to 0.39 into 10 to the power minus 10 meter. The answer is option C. 10th question. The probability of penetration through finite potential barrier V0 of a particle with kinetic energy E increases with dash. The answer is option A, decreasing V0 minus E. 11th question. The angle of contact between glass capillary tube of length 10 cm and a liquid is 90 degree. If the capillary tube is dipped vertically in the liquid, then the liquid will neither rise nor fall. The answer is option D. 12th question. In the following equation, which one is related to phase of resonance? The answer is option A, tan alpha equal to mu p divided by k minus mp squared. 13th question. When source is moving away from the observer, what is the change of frequency of sound? The answer is option D, f dash equal to V divided by V plus Vs into f. 14th question. In a damped harmonic oscillator, the amplitude is dash. The answer is option C, decreasing. 15th question. The resultant force of vibrating body is dash. By seeing the four options, we can easily found the answer is option A, because for a vibrating body, a driving force is necessary. Hence, the answer is option A, periodic driving force, the elastic restoring force and friction force. 86th question. Loudness and intensity are related to each other by the relation. The answer is option C. L is proportional to log I. 17th question. What are the necessary conditions to get beats? The answer is option A, when two notes of nearly same frequency and amplitude. 18th question. A uniform spring of force constant K is cut into two pieces of equal length. What is the force constant of each piece? Let's see the solution. K is the force constant and let L is the length of the spring and L dash is the length of each new pieces, where L dash equal to L divided by 2 and K dash equal to new force constant. The force constant is inversely proportional to L, that is K is inversely proportional to L. This implies K into L is a constant. Therefore, K into L equal to K dash into L dash. Substitute L by 2 in the place of L dash, we get K dash into L divided by 2 equal to K into L. Cancel L on both sides. Hence we get K dash equal to 2K. The answer is option A. 89th question. Calculate the pressure inside an air bubble below the water surface. And the data also given. Let's write the given data. Surface tension T equal to 72 into 10 to the power minus 3 Newton per meter. Atmospheric pressure P naught equal to 1.012 into 10 to the power 5 Newton per meter squared. Radius of the air bubble R equal to 10 to the power minus 4 meter. We have to find the pressure inside the air bubble. Solution. The excess pressure delta P equal to pressure inside the air bubble Pi minus atmospheric pressure P naught. The excess pressure inside an air bubble delta P equal to 2T divided by R. Let's find delta P. Substitute the values, we get delta P equal to 2 into 72 into 10 to the power minus 3 divided by 10 to the power minus 4. After simplification, we get delta P equal to 1440. We have to find the pressure inside the air bubble Pi equal to delta P plus P naught. Substitute the values. We get 1440 plus 1.012 into 10 to the power 5. We can write 1440 as 0.0144 into 10 to the power 5. By adding these two terms, we get the answer as Pi equal to 1.0264 into 10 to the power 5 Newton per meter squared. Hence, the answer is option A. Question number 90. A quartz crystal of thickness 0.001 meter radiates ultrasonic wave into water of frequency 20 kHz and intensity 5 into 10 to the power 4 watts per meter squared. Calculate the maximum acceleration. Given data. Thickness T equal to 0.001 meter, frequency equal to 20 kHz, which is equal to 20 into 10 to the power 3 Hz, intensity I equal to 5 into 10 to the power 4 watts per meter squared. We have to find the maximum acceleration A max. The formula is A max equal to omega into root of 2I divided by rho into V, where rho is the density of water, its value is 1000 kg per meter cube, and V is the velocity of ultrasonic sound in water, its value is 1500 meter per second. We know omega equal to 2 pi f. Hence, maximum acceleration equal to 2 pi f into square root of 2I divided by rho into v. Substitute the values, we get 2 into 3.14 into 20 into 10 to the power 3 into square root of 2 into 5 into 10 to the power 4 divided by 1000 into 1500. After simplification, we get 125.6 into 10 cube into square root of 10 to the power 5 divided by 15 into 10 to the power 5. We can cancel the terms 10 to the power 5 and 10 to the power 5, and we can write the root term as 1 divided by root 15, and we can take root 15 as approximately equal to 3.8. Hence, A max is approximately equal to 125.6 divided by 3.8 into 10 to the power 3, which can be written as 1256 divided by 38 into 10 cube. By cancelling the terms, we get A max is approximately equal to 33 into 10 cube meter per second squared. In the option, the correct answer is not given. Actually, this problem is taken from the engineering physics book in the chapter acoustics and ultrasonics. In that problem, the intensity value is given as 10 to the power 6 watts per meter squared. Let's redo the problem again by substituting the intensity value as 10 to the power 6 watts per meter squared in the place of 5 into 10 to the power 4 watts per meter squared. Intensity I equal to 10 to the power 6 watts per meter squared. A max equal to 2 pi f into square root of 2I divided by rho into v. Substitute the values, we get 2 into 3.14 into 20 into 10 cube into square root of 2 into 10 to the power 6 divided by 1000 into 1500, which is equal to 125.6 into 10 cube into square root of, we can write the numerator as 20 into 10 to the power 5 divided by 15 into 10 to the power 5. Cancel the numbers in the square root. We get finally square root of 4 divided by 3. Root 4 is 2 and root 3 is 1.732. Cancel 2 and 1.732, we get in the denominator as 0.866. Now cancel the numerator and denominator, we get 62.8 into 10 cube divided by 0.433, which can be written as 628 divided by 433 into 10 to the power 5, which is approximately equal to 1.45 into 10 to the power 5 meter per second squared. Here comes the correct answer. Hence, in the problem, the answer is option A. Thank you.